Hi there, I'm Dr. Daniel Perez Grande, and I'm the CEO and co-founder of ienai Space. Today, I'm excited to show you something we've been working on very hard for the past year. ienai Go, the world's first rocket design software as a service, or as we like to call it, rocket design as a service. ienai Go is a concurrent mission and propulsion system preliminary design tool. Through it, you can obtain optimized trajectories, propulsion requirements, and a preliminary design of our ATHENA thruster under multiple constraints. It is a user-friendly, fast, and robust software, and it has been benchmarked against industry reference tool GMAT. Best of all, it's completely free, with open access for anyone in the space community. ienai Go is just a starting point of your journey towards designing your mission in an optimum way. Once you have explored the preliminary propulsion requirements in the design space, we'll be happy to get in touch and perform a higher fidelity study through our in-house mission analysis tools. We'll give you all the information you need to make informed design decisions for incorporating electric propulsion in your mission. ienai Go is currently up and running in its first version, and today we're going to show you how to start designing your first maneuvers and thrusters. We'd love to receive your feedback in order to make the tool better for everyone, so don't hesitate to contact us. And now, let me introduce you to Borja, who will be your guide in this video tutorial.
Thank you, Daniel. I'm Borja de Saavedra, propulsion engineer at ienai Space, and today I'll be your guide for ienai Go. I'm going to show you how to create your first mission and build your optimum ATHENA thruster. First of all, you have to go to go.ienai.space and click here in the Join Beta button to register. It is very simple. After that, you can directly sign in. All your missions will be stored in your account and shown here in the home page. Let's go ahead and create our first one. First of all, you have to set up the configuration of your mission. You can select a custom platform specifying the total mass, frontal area, and total power, or select the standard CubeSat specifying the number of modules and the solar panels. Next, you're going to determine the thruster envelope, selecting first the maximum power to the propulsion system, the pointing, that is whether you thrust along the main axis of the satellite or on one side, and the limit of the mass of the thruster. Finally, you're going to select the initial orbit, whether it's circular or elliptic, specifying the altitude and the inclination. Once you save the configuration of your mission, you'll land on the maneuver scenario view. Here you'll have a dashboard as a summary of your configuration, of your current status here, and also tabs for each of the maneuvers that you select. Also, you can go home here and give us feedback at any time, whether it's ideas or suggestions, bugs, or any other feedback you want to give us. We can now select our first maneuver. In this beta version, there are 4 types available: run facing, station keeping, orbit transfer, and deorbit. Let's go for run facing. In all of the maneuvers, you'll have to set the input in the left-hand side. In this case, you can restrict the altitude limits, and of course, you have to specify the run shift. ienai Go is going to calculate first, for the input you gave it, the shortest possible duration for your platform. If you click on Calculate Maneuver, you'll see the results of this shortest maneuver. You can see here some results like the thruster power, propellant used, specific impulse, thrusting time, maneuver delta V, and in the particular case of run facing, also the total altitude change. You can also see here a time profile of the orbital elements of your maneuver. If you can afford a longer maneuver duration, you can increase it so that ienai Go will optimize the propellant mass instead of the time. After a little while, you can see again the same results with less propellant mass consumed. You can then click on Save, and the status dashboard and the Maneuver tab will be updated. Let's go ahead and add a second maneuver. In the case of the orbit, there is no additional input required, so ienai Go directly computes the shortest maneuver possible. After that, you can click Save and then go to the mission overview to see the results of the mission and the propulsion system. In the mission overview, you'll notice first in the center a pentagon-shaped chart showing the main propulsion parameters of the mission: the thrusting time, delta V, propellant used, thruster power, and total impulse. You can also toggle here to go to a table view of these parameters and also the specific impulse. On the left-hand side, you'll have the maneuver cards with which you can revisit the duration, requirements, and results of each of them, and also view again the plot in time of the orbital elements. On the right-hand side, you have the true result of ienai Go, your optimum ATHENA thruster for your particular mission. You can see here the main parameters of the thruster and also a 3D view. Finally, here, you'll be able to download a CAD file of the thruster and also get a PDF with a mission and thruster summary after you contact us for the first time. All right, that's all from me today. We hope you enjoy ienai Go and get the most out of it. Please do give us your feedback through the built-in function, and for any other matter related to propulsion, do not hesitate to contact us directly. Thank you and see you in orbit.